Whenever you have a system that comprises of more than one gas, you have a little bit of a change to the composition of a gas. Obviously, if it's not pure, you've got two different gases doing two different kinds of stuff to everything that's around it. Okay? But because of partial pressure, we can sort of figure out what the percentage of each one of those gases are inside of a system. It goes like this. If I have total pressure within a system, we can measure that very easily. The total pressure is going to be a sum of all of the different gases that are in the system all the way until the end. Okay, so whatever gases we have, if it's an air mix, we'll have nitrogen gas, oxygen gas, a little bit of argon, carbon dioxide, water vapor, a little bit of N2O, NO2, other things, neon is floating around in the air. A lot of different things that comprise our atmosphere add up to these pressures. Okay. Now, if we relate that to gas law, we get a little bit of an interesting correlation here. All right. So what this means is that all of these different pressures, if I look at the total pressure of a system, right? Remember, PV equals nRT, right? So I've got that, right? The total pressure, the total number of moles that's in the system is going to reflect the total pressure that's in the system, right? So the total number of moles and the total number of pressure is related. And what I can say when I look at this is say, well, if I keep volume, gas law, obviously gas law constant, and temperature, keep those all constant, I can take those and make them a relatable value between each one of the materials that's inside of the gas. So what do I mean by that? I'm glad you asked your computer. You're looking kind of crazy, but I forgive you. Okay, so PT over NT right now is equal to VRT. Okay, oops, excuse me, not VRT, it's RT over V. Getting a little excited because this is so cool. All right, so this is pressure total, and this is gas number of moles total. All right, and they're relatable in the fact that they're equal to this function. Another way of writing it is to say that the total pressure in this system, okay, is equal to the total number of moles times RT over V. Now what this means is that when I get here, it means that they're relatable. Okay, so that means that whatever fraction I have of gas in a system is going to be related to the number of moles that's in a system. Okay, if I think about it this way, if I look at P1, how do I determine the fraction of P1 that's in my system? So I look at it and I say the mole fraction, or actually the partial pressure at this point, the partial pressure is going to be equal to P1 over PT. And whatever that fraction is tells me what percentage or what fraction my P1 gas is contributing to the overall pressure as a whole. Okay? All right. So let's go to different color now. The same type of thing, the same type of relation, we're going to be looking for something called mole fraction. And mole fraction is going to be x1 over the total number of moles that are inside of a system. Now you see where I'm going with this. Okay? If I have a fraction of moles and a fraction of gas, and they're both relatable here, what that means is that the partial pressure of 1 is going to be equal to the moles of 1, right, times RT over V. Okay? So that's how these things are relatable. All right? Another way to look at this is to say that the P1 value, another way of looking at this is to say that P1 over PT is going to be equal to N1 over NT. Okay? Why? How do we get there? Well, if I do this, RT over V on both sides, okay? Both of those cancel out. Yeah? And if I say that my mole fraction, X, mole fraction, is equal to N1 over NT, then I can take this entire term and reduce it to something that's a little bit more relatable. So my partial pressure is going to be equal to X, which is the mole fraction of whatever that component is. In this case, X1. So the mole fraction of 1 is going to be the amount of pressure that I have versus one component over the rest of it. Alternatively, I can look at this and say whatever my mole fraction is, I can multiply. So let's see, can you see this? Yeah. All right, x1 times pt will give me the partial pressure of that gas inside of a system, so long as I know the moles. Okay? So that's how we do those. Those types of things are relatable.